events discouraged. We should change our plans.
What? Best? No. Shit happens.
I'll say we'll start next week. Hello and welcome to TVR Working Group. I believe it is time now. We do have a pretty packed and eventful schedule, and we're going to try and keep 10 minutes as best we can, 15 minutes at the end for some open mic discussion. But otherwise, we would like to get started.
All right, let's go. Next slide. Okay, this is the Note Well session. If you've been here before, you've read this before, please read it again. Next slide. Note really well. Please don't be a jerk. Being a jerk causes us to be jerks. We don't want to be jerks. Yeah, ADs having headaches is par for the course. Sorry. Next slide. Okay, it's Thursday. You've probably seen this before. Please use the tools. If you're in the room, please scan the QR code. Next slide. Here's the agenda. Here's the Meet Echo. If you need technical assistance, here's the link to that. And finally, here's our agenda. Lots of talks. Our time is almost completely full. Is there any agenda bashing? Going once, going twice. Okay, let's move on.
And then there were one or two minor changes to the agenda. We reordered one or two of the talks. So if you are here and presenting, please make sure that you understand your spot where it is now. And then second, we would ask that people join the note-taking, the shared note-taking app. The more note-taking we have, the better. And also, I know that Adam, our secretary, is online and will also be taking notes throughout the session. All right. Well, with that, our first presentation is going to be Ying Zhen, who's going to be giving us an update on use cases. Yes, I can drive the slides. And I will put up just one moment.
Hello everyone, this is Ying Zhen from FutureWay. I'm gonna present an update of the TVR use cases document on behalf of the co-authors. So in this document, currently we have 3 categories of use cases. And I'd already did a very detailed presentation at last IETF about all these use cases. So I won't bore you with repeating all those details again, but for everyone's benefit, I'll just do a quick recap of all these 3 categories. So the first one is about resource preservation. So this is very much relevant to the kind of networks that has constraints such as power, storage, etc. So from network point of view, we will have that link activation, deactivation, or a node that's on and off based on a schedule. The second category is about operating efficiency. So this is a network that operates with a time varying cost. And so also to a network, this will involve schedule a link cost based on time. The third category is about mobile devices. This is all the use cases that cause network topology changes or any attribute changes because of motion or mobility. So this may, from network point of view, we may have link on and off, path attribute, bandwidth change, etc., or neighbor changes. So after we published version 01 before IETF, we had good discussions on the mailing list. We received a lot of comments from the list. So I try to make a summary here. If you think I missed your important comments, please speak up after my presentation or contact the authors offline after the meeting. So the first one is about title network. So from the name, you can sort of tell is this try to describe the kind of network, the traffic changes, sort of like a tidal waves, right? So a typical example is a university campus. We have the traffic, that network traffic all goes to classrooms, library in the morning and go back to dorms or out of campus in evening. So there is a draft in TVR on this one. So I think at least from the mailing list discussion, we agree this should be added to the use case document, and we will work with the draft author on this one. Another comment is about satellite. So the suggestion is we should include satellite, not just LEO satellite, something maybe like we call MEO or GEO, and our interconstellation communication. So to me, if the movement of the satellite or the impact to the network can be described using a schedule, I consider it's already covered in the use case document. But if you think differently or you want to contribute, make more suggestions about this side, please contact us. The third one is about wording. So right now we have it in the document. It's called mobile devices. The suggestion is to change it to dynamic reachability. And I think we reached consensus on this, and we'll change this in the next version of the draft. The last one is about predictable mobile nodes, such as cruise ships or commercial airlines. This actually is also related the sort of movement that can be described using a schedule. And the authors believe we already covered this in the use case document. If you think we need to provide more details or more about the use case, please let us know. Okay, so and then what should not be covered by TVR? So you may already see TVR charter, and so here are the use cases we should clearly not covered in the use case document, like mobile end users, smartphone movement, unpredictable mobility, such as vehicle to vehicle communication. That should be covered, I believe, in mainnet. And also, unplanned topology change, such as unexpected network failure, link, whether it's a node failure or a link failure.
Do you want to take questions now? Or?
I just have one more slide.
All right, we'll do one more slide and then take questions from the queue.
Okay. So for the use case document, we don't have a intention. We are not intended to list all possible use cases. That's just but we try to include enough good examples so we can have enough knowledge to make an abstraction to figure out all the impacts to the network. Really, if you look from network point of view, we care about whether you have a scheduled node on and off, change location, yes, link on and off, or change attributes such as cost, delay, and whether your adjacent neighbors may change. Like in LEO satellite, your neighbors may change. And what's currently not covered in the use case document is when we have a network, the traffic, we have a predictable traffic pattern. For example, you may have between data centers, they have a, for example, data backup every night from 10 o'clock to 12 o'clock in the evening. So whether we want, this is not going to cause any topology change, but it's a predictable traffic pattern. But it's not currently covered in the use case document. So I want to get the opinion of the working group to see whether we want to cover it in the use case document. So speak up. That's it. And all the reviews and comments are welcome, and we'll continue refining this document.
Erishman?
Hello, Rashmit from Warwick, Canada. Back to your slide 3, I think that it might be worth to actually clarify what we mean at the bottom of the slide 3 when we talk about mobile nodes. I understand what you mean, but maybe we should make a distinction between mobile nodes and mobile terminals when the source and destinations are moving along a path, a predictable path like ships and things like that. Because a mobile node conveys the information like, okay, a router is moving or a satellite is moving and so on. So we might want to clarify that a little bit. As far as your last concern, the last point that you brought up, I totally agree. We should actually bring in the predictability of the traffic. As you mentioned, a good example, your first example, for example, the campus traffic, for example, it sort of like cools off and goes somewhere else, during nighttime. So I totally agree with that. Adding that to the use cases.
A little bit difference between the title example and the predictable traffic pattern is, for that one, the network administrator may choose to turn down some interfaces,
right?
So that actually may cause a topology change, not because of any network constraint, but just because of the traffic
Absolutely.
pattern. Yeah.
Yes.
The last one I mentioned is now covered in the use case document. Is you just simply have maybe some expected traffic flow coming in, but that's not causing topology change,
right?
But just a traffic
it's
pattern.
Just a traffic,
so you may,
basically.
you may want to move things around.
That's right. Yeah, exactly.
Yeah, for the clarification about predictable movement, I try to clarify that. But
Lou Berger, do you mind going back forward one slide? Sorry, the slide 4. So you have here unplanned topology change is not covered by TVR. So this is a comment on the slide, not actually the document. The document, I think, says these things can happen and they're handled elsewhere. Saying unplanned topology, the way it's phrased here sort of says like, yeah, we don't deal with that and we're not necessarily compatible with it. And I think that's misleading. So it's more on this slide because unplanned topology changes will happen and they will be needed to be dealt with part of the system. It's
right.
just not part of the TVR piece, but TVR might have to do some things to make sure it works with both scheduled and unscheduled link changes.
Yeah, we actually, TVR, the schedule need to consider this. By the time that schedule happens, there may be something unplanned already happened. Yeah.
One last thing. So it turns out that as a working group, we are supposed to produce a problem statement. And we actually put it in our list of milestones that the problem statement is supposed to be part of this document. So I'm asking, as document shepherd, could you please add a section and a paragraph or 2 about the problem statement?
So we have a requirement document.
So the problem statement is supposed to go in with use cases.
So you are saying we should add a section just to make a clear problem statement?
Yes, if you can, I think we have something of a handle, so we should be at a point where we can draft a problem statement at this point.
Yeah, okay, we'll do that. Rick?
Hi, Rick Taylor. I have a problem statement. I wrote it for the BOF. I'm very happy to donate all the text to you. So, so don't panic too much. We have a starting point.
Please remember to email us.
I will do.
Yeah, thank you.
Rashman again. One more quick note. It's quite possible that we have to consider the fact that, once we are predicting something and that prediction doesn't come true, then what we have to do, that might as well be part of the use cases if you want to mention it in there. So for example, the schedule is telling me that a link, for example, in satellite is going to come up within this time slot. And then, but for whatever reason, now that link will not come up. Now, what happens is that, especially in the satellite case, this thing will go around the Earth, and we have to sort of have a mechanism in place to back it off. So this is different from what we have in the terrestrial network, when the link state protocols basically will just work that way. But here we have predicted that something will happen. It didn't happen, and now we have to put a mechanism together to back it off. So if you want, I can actually.
I guess we need to discuss more
Right,
about
absolutely,
this.
yeah.
Personally, I don't think if you tell me if I'm a router, you tell me a fake schedule, how am I supposed to know that's fake?
No, it's not fake. It's just like, for example, Leo is going to go around the Earth, and then we have an almanac that tells you at time start that the interface between node 1 and node 2 is going to come up. And now something hits the laser beam or the radio of the satellite A on that interface, and it brings it down. Now everybody has predicted, at the time of the clock, everyone basically went in and moved their prediction algorithm one slot further, and they are assuming that the interface is up. Right? So now that interface that prediction is no longer valid. So we have to create a mechanism to back off that prediction from everybody.
Okay, I see your point. Right. Thank you.
If you want, I can actually, I have the documentations for it. I can actually add it to you, give it to you to add it to the draft.
Yeah, we can discuss more offline. Yeah.
Is that a use case question, or is that actually about the solution?
No, it's not the solution. I'm just like, we can actually add that a consideration, maybe a section or something like that, that this can happen as a part of the mobility use cases.
Then that would seem like a requirement.
Yes, actually quite right. Yeah.
So yeah, the requirement will be presented next.
And then one more.
Okay.
Yeah, hi, this is Gargi. I'm curious about the last one. Like, why do you think the unplanned topology changes should not be covered in TVR? And if so, where do you propose it should be covered? Why is it different from planned topology changes? Because these are probably very frequently that these happen as well.
So TVR's charter, we are talking about planned network topology change or network attribute change based on a schedule. So unexplained topology change. So for example, if you have a link failure in your network, that's already handled by fast rerouting today.
And
yes, but there could be others which may or may not be handled. It may not be a link failure. It can be a complete node failure, but
yeah, even link failure or node failure are handled by FRR today, and that's not within the charter of TVR.
So it should be, you're thinking it should completely be addressed by FRR and TVR should stay away.
Not here.
Well, just with Chair Hadwan, from a scoping perspective, TVR's initial charter was to focus on planned. And part of the idea there was that we do have other working groups like MANE for ad hoc changes, and that would be another place to look at solving that problem. If we find that there is area that is not well covered across the working groups, then of course we can talk about that in rechartering and as we go forward. But the initial charter felt that the planned cases were complex enough. So let's start there and then see what we have to do later.
Okay. Any more questions? Thank you.
Thank you very much. Okay.
Aislinn, I got a quick one. I forgot to cue, but Aislinn Lavin. I just wanted to say that as we get into the solutions, the interaction with unplanned changes will be covered, probably have to be covered in the solutions. But like you said, they're not part of the charter.
Yes, completely agreed. So our next presenter is Jing Wang, who's going to be going over requirements and and give me a moment to put the correct slides up. So we have, which ones are they? Is it routing considerations?
Should be in order.
It's not in order. Yeah, we are. Okay.
Can you hear me?
Yes, we can hear you.
Yeah, okay. Hello, everyone. This is Jin Wang from China Mobile. I'm here on behalf of authors to report the draft about consideration for TVR requirements. Next slide, please. Okay. Before introducing the requirements, I would like to give an overview of the TVR. As we all know, there are three use case has been defined in the use case document. The first is resource preservation. One example of this use case is an energy harvesting wireless sensor network or WSN. The second is operating efficiency. One example of this use case is a set of nodes operating over cellular connections that charge both on peak and off-peak data rates. The third is mobile device. Some examples of this use case are vocal-to-vocal communications, low Earth orbit networked constellation, and so on, are the network compositions of these use cases the same? Obviously, I think is inconsistent. So the first requirement is supporting identification of time variant nodes and non-time variant nodes. I think in the use case of time variant routing, there may be two types of network composition. One is composed entirely of time variant nodes. For example, the location of network nodes in LEO will change from time, and the other is composed of time variant nodes and non-time variant nodes. For example, some network nodes have different power supplies. Some network nodes can be continuously powered, while others may change over time. So I think must provide a discovery and resolving methodology for the identification of time variant node and non-time variant node. Next slide, please. Okay, the second requirement is supporting different advertisement strategies for time variant nodes and non-time variant nodes. Uh, as previous slides, there may be two types of nodes in the network, namely time variant node and non-time variant node. In TVR, the information advertisement of nodes needs to be advertised in order to make routing decisions. Redundancy of information advertisement in the network is a typical problem. In the use case of time variance routing, the advertisement of time variance nodes will affect the routing decision. If time variance nodes and non-time variance nodes adopt the same advertisement strategy, advertisement overhead may become larger. Therefore, must support different advertisement strategies for time variance nodes and non-time variance nodes. Next slide, please. Okay. The third requirement is supporting classification of time variance nodes. There are time variance nodes and not time variance nodes in the network. So the information change of each time variance node may affect the routing decision. However, the influence of information change of each time variance node on the routing decision is inconsistent. This related to the change trend of time variance node information over time. It's helpful to send different advertisement strategies for different time variance nodes through the classification. So I think must provide a classification methodology for classification of time variance nodes. Next slide, please. Okay. In addition to the above requirements, I believe that some requirements should also be provided for the advertisement strategy, such as routing strategy, strategy, advertisement strategy, metric representation, security, and so on. We will continue to contribute and pay attention to the requirements. We hope our proposals can be helpful to WG. So thanks.
Thank you very much. And we do have one person in the queue, Rick.
Rick Taylor. I have a question which may demonstrate my lack of knowledge rather than a problem with this, but I don't know what a time variant node is. If it is something different, then sure, yeah, let's make sure we can identify that it is something different. But I suppose this underlines my concern that I think this might be the wrong approach to start a classification of nodes rather than looking at how existing nodes which are running existing routing protocols could be augmented to understand that there is some time variance in the decisions that they are making. But I could consider scenarios where being a time variant node is simply a configuration option, and it might change over time itself. I think it's very rigid. I just, this doesn't work for me. Perhaps I need to go back and read a bit more of the supporting material, but can I actually go back to the question? What is a time variant node?
Yeah, I will give you example. Yeah, in some networks, some nodes are powered by a constant power supply, and some nodes are powered by green energy. In this case, the node powered by green energy could be called as time variant nodes, and another is could be called non-time variant nodes. The difference is uh, uh, they they might be might, might be changed from time. Yeah. Yeah.
Thank you. I think I do understand where you're coming from. Is to some way to classify a node as being subject to time or being time variant sensitive. But I would suggest that that property itself is time variant. I could have a node. My mobile phone, I can plug it into the power, and it's therefore got a sustainable, regular, apparently, power supply, or I could remove the power supply and then it becomes battery powered and could in some ways be, time variant. I think a very strict taxonomy of time variant node and not time variant node may be a mistake.
Thanks.
Chair hat off. I agree completely. It seems to me like there are nodes that have pending scheduled items and nodes that don't. And you can flop back and forth between the two.
Oh, thanks.
Raj?
To continue on what Rick said, probably since this is a requirement, we can actually add a section in there to say actually a time variant node can actually optionally just remove itself from that. And this information has to be sent around again in the protocol that you're trying to devise, basically, right?
Okay, thank you very much. And we will then move on to our next presentation, which is Brian Sipos with another set of TVR requirements.
Okay, I'm Brian Sipos, and I'm speaking on behalf of the other co-authors of this document. Next slide, please. So this draft was recently published. There's still a lot of TBDs in here and still a lot of things that need to be discussed and worked out. But we feel that it's a good starting point. And what this is doing is it's trying to achieve the charter item of documenting basic definitions and requirements of what TVR means. So the use cases are explaining what are the situations that exist. And this document is supposed to be taking a stab at identifying nomenclature and explaining what the systems that deal with those use cases should, shall, and may do. So it's a combination. It's not a augmentation of an existing protocol. It's explaining what these protocols should and should not do. And the goal is to link back eventually to the use case draft to point out specific purposes and rationale for why these things are requirements of TVR systems. Next slide, please. So we give a definition, a very general purpose definition of what a time variant network is. And one relation to what we were just talking about is the way that this view of things sees the world is that it's the network itself which is time variant, not an individual element of the network. We use terminology from existing modeling documents in the IETF so that we know what a node is, what a link is, what a interaction point, I think it's called, is. But it's the network itself that's time variant. And the reason for this is that either, sort of what we were just talking about too, is that either nodes in the network, systems that operate in the network or talk about the network, either they do understand time variance or they don't. So having a node in the network that doesn't change state over time doesn't affect the fact that the management of the network or the links of the network or aspects of the network itself can change over time. And there's a lot of different things that possibly could change within a time varying network. Some of these are attributes of nodes, some of these are attributes of links. And what we're trying to do here is capture some basic terminology and some basic notion of how these can be modeled. And then the one thing that is, I don't believe it's a specific slide item here, but it is important to focus on, and it's important to have a discussion about, because it affects understanding of how these systems are operating. It's documented in the draft currently, but it's not a separate slide right now, but maybe it deserved to be a separate slide, which is a distinction between a schedule timeline and a wall clock timeline. And any system that models this kind of thing, or any system that has to deal with this kind of thing, has to consider both of those things as independent but related aspects. And in the past, management protocols, routing protocols, and these things deal with changes in wall clock time because they have to. If you enable an interface or enable a link, and like we were saying earlier, the link doesn't come up, that's just a fact of life. That's things changing over wall clock time. But what we're trying to do with these requirements and with TVR generally is to describe how things change in schedule time. And ideally, schedule time would play out exactly as we planned it in wall clock time, but in fact, there can be differences. But it is important to distinguish between these two completely separate timelines of activity. And when you're talking about things changing over time, it's also important to be a little bit more clear in whether you're talking about things changing over a scheduled timeline or things changing over wall clock timeline. Next slide, please. So the scope of this document is we're starting with the use cases as a basis for why is any of this happening. And then we're discussing what can be modeled, what are the different aspects of models generally of a network, and how schedules can fit into these things. The next group of items here are some terms that are being defined in this document. These terms are a first go at putting concrete definitions to them. So we'll welcome feedback about these details, about how they're written now, about if anything's missing or if anything is confusing. We want these terms to be as clear and understandable as possible. And some of these things have major effects on the capability of a time variant system. So things like time precision of the model itself greatly affect how that model can operate, in the sense that if your model operates on the time precision of 1 hour, then your wall clock time certainly is going to evolve as reality does, but your scheduled time is then constrained that it can only evolve in 1 hour increments. And maybe in certain applications that's sufficient, and maybe in other applications that's wildly insufficient. But these are aspects of models. These are not, this part of the document are not requirements on models, but they are requirements on what models must consider about time variance. Periodicity is another big one. There are existing systems that model time variance, but don't include a notion of periodicity. And that simplifies things a lot, but it also limits things a lot. So going back to what are these requirements really, we are not going to require that a TVR model include something like periodicity, but that these models must consider periodicity, because going back to the difference between schedule timeline and wall clock timeline, in wall clock timeline, as we were talking about earlier with orbital systems and with tidal systems, things do change periodically. Your model might not have a notion of periodicity intrinsic to it, but the thing you are trying to model does have a notion of periodicity. So if there's a disconnect there, that could cause some inefficiencies or cause some misalignments. So things to consider. Continuity and interpolation are in that same vein, that wall clock time, as far as I know, is continuous. things evolve over actual time at different rates. But a model doesn't have to be continuous. And as a consideration, this is saying, well, for a model to do its job well, it probably should enforce some notion of continuity. And that could be intrinsic to the model, or that could be some kind of validation that happens on data feeding the model. But again, just a consideration of a system that deals with scheduled time should at least address these concerns. And interpolation is related to continuity in the sense that some things deal well with discrete changes in state, but some systems, again, going back to the scheduled time versus wall clock time, if the real system being modeled varies more slowly and more continuously, a discrete changed model might capture that well, but in other circumstances, it might not capture it well. So continuity, interpolation, and then time precision, like I was mentioning before, all play a factor in how well can a model capture the nuances of the real system. And then lastly, the terminology of nodes, links, and the attributes of those things are taken from an existing document. And just to call it out here, because I was trying to recall this, this is the RFC 8345, the data model for network topologies. And the goal here is to hopefully build on what's already standardized in, as far as naming these things and systems that deal with modeling these things. Next slide, please.
So Brian, just before we go off, a quick question, chair hat on. When we talk about the descriptions of these definitions, temporality, time variability, time horizons, and so on, is it the intent of this document to make them relative definitions to understand the requirements, or is the intent to make these the normative definitions of these terms for the TVR working group at large?
The goal would be that these are definitions for the terms that other specifications would not need to reuse. That doesn't mean that everybody has to agree on them, but if you say a term and you cite this document, you don't have to re-explain all of the world around what that term means.
And I do agree with that. One of our charter items is to make definitions of terms common to what we are doing here. And so putting that as part of the requirements document is a reasonable place to put it, as opposed to a separate document. And people would point here to understand those terms. All right, thank you.
So right now we have really one illustrative example of a very complex time variant model, and that is the FAA's Aeronautical Information Exchange Model. And this is highly complex, but also highly expressive. This represents a kind of a reference of how difficult a model can be to try to capture a lot of nuance from reality. This is not intended to be an example that we would adhere to for TVR models, but it's intended as a point of reference to say how complex something might be, but also how expressive something might be. The intent of probably how TVR models are going to eventually evolve is going to be considerably simpler than this, and considerably more narrow in terms of time horizon. That was one thing that was mentioned in the last slide in terms of terminology, is that a model could attempt to handle the time horizon of many years, but that adds a lot of complexity, and that adds also a lot of situations where your schedule timeline starts to deviate wildly from your wall clock timeline because you don't necessarily know what's going to happen in multiple years. But you can have a model that is limited in time to a few days, a few months, and maybe achieve better adherence to reality. So also for examples, there are some existing models that come from the delay tolerant networking domain. They are in some cases less complex and less expressive. We don't have one model to rule everything. So, but we still would like to point at some existing models to use as again, examples of what does an existing system look like and how does it fit into these set of aspects that are defined in this document. So it's an open call to say, are there existing models that are TVR-like enough that we can point to and say, okay, what does this model look like when viewed through the lens of these aspects that we're defining in this document? Next slide, please. And then similar to what was mentioned on the first presentation today, talking about what's not in scope for this document, we're not talking about requirements on specific models of specific schedules to existing routing protocols or management models. We're talking in general terms into if something is going to call itself a TVR model of a network, what does it need to consider and how should it describe itself? This is similar to how draft and specification documents now have security considerations sections. And the enforcement of the presence of the security consideration is important. The contents of the security considerations are tailored to the specific use case, but the idea is that if you are modeling a network system, you have to consider security. You don't have to have certain kinds of security, but you have to explain what it is and how it fits in. And the goal here is to do the same thing. We're explaining what things a model should say of itself so that somebody can understand what it's doing and what it's not doing. And then the other main area that's not in scope is how an implementation should operate. And so this is not talking about where does this information come from. It doesn't talk about how does the information get distributed among a network. And it doesn't talk about how, it doesn't talk about specifically how a model can be implemented in a device, but some of the aspects such as time horizons and time precision affect how a device could execute a time variant schedule. Because if a schedule has a very fine-grained precision to the time in the schedule timeline, but the devices implementing it have very coarse-grained clocks, then that's something that's probably not going to behave very well in practice. Next slide, please. So that's it for this talk. We still have a bunch of time left, which I'm hoping we can get some feedback in. There is a draft now available. Like I said, it has sections that are TBD because we're wanting to get feedback on the initial information that's in there. And we're looking to expand on what's there. We have a GitHub project currently stood up that people can write issues in and get some feedback in the document itself. And then it's a general question is eventually getting a working group adoption of the document. Right now with the TBDs, it's probably not fully in that state, but once we have some information filled out and an outline generally stable, would be requesting adoption.
We have a couple of people that just joined the queue, starting with AC.
AC Lindum Levin. I saw you talk about a schedule, different types of schedules. One that's a schedule and one that is based on what did you call it? Clock on the wall time?
Yes.
Clock on the wall time. Wouldn't a schedule, if you take a schedule and you apply it to the parameters of the schedule, couldn't that always, do you see cases where that would not be flattened out to something that maybe not in the specification of the schedule, but in the implementation would be based on clock on the wall?
Yes. Yeah. The expectation is that a proper system should implement a schedule, should follow the schedule timeline, and the real implementation, the real execution in wall clock time should agree with that. That would be the ideal situation. But
okay.
The reason for distinguishing those terms is to talk about how things change And when you're saying a thing is changing, it's very important to distinguish, do you mean it's changing in the schedule, or do you mean it's changing in reality because of a switch was flipped or a link was down?
Right. I think I have to think about that. Would you say there'd be instances where a schedule changed based on dynamically?
Yes, and there's some discussion in the document about this,
Uh-huh.
but there's a notion that a model has state, and the schedule is inside that model state. The model state has a full schedule.
Right.
It adheres to whatever the model, the horizon, the granularity. The model has a state within it. That state of the model actually changes over wall clock time. The expectation, and it should be something that is required of TVR systems, is you don't make a schedule once in a lifetime and you're forced to stick with that schedule. It's not already, but it ought to be a requirement of a TVR model that it is allowed to change over wall clock time.
Okay.
The schedule should be allowed to change. You shouldn't be.
It should be allowed to change, but that would take a reconfiguration.
Yes.
Okay.
Exactly. And that's
because that if it doesn't, that takes away the predictability of it.
exactly.
Anyway,
If I had a system that I could configure one time ever, and if I ever wanted to change it, I had to tear the system down and rebuild it, that would be a nightmare, right? But my schedule, if it was perfect, would never need to change.
Hi, Lou Berger. Before you had a list of parameters, where are you thinking we're going to define metrics, values, scales, those types of things? Where do we define the details of that? Are you thinking that that's going to be part of the requirement?
So currently, there's some discussion in the document about augmenting existing models, about taking a model that's not time variant and figuring out how to add scheduled information into it. And the concept is that a schedule augmented model should have the same things being modeled as the non-augmented model, but it's up to the detailed implementation, the detailed specification to say these things are allowed to change based on the schedule. These things are not allowed to change. And one thing that is a carryover from the Axim model that is useful to have in this kind of thing is that identities of things should not change over time, but other attributes of things should be allowed to change. In the Axim model, anything and everything besides the identity can change over time. But in a realistic TVR network model, it's probably going to be restricted to specific things, but what those things are is up to the individual model.
You said something earlier when you were presenting about commonality. And when we get to commonality, it's probably pretty good to have common units and common degrees of precision, common ways of expressing. In other work in IETF, we've sometimes translated that to what we call an information model, which is different than a data model.
Yeah.
We had some discussion, I think, in chartering about information models. Are you thinking that this is going to end up in an information model, or are you thinking that you're going to just put it here and then all the implementations will derive from there?
I think the requirements could inform an information model, but my personal expectation is that the existing protocols and the existing management systems are probably different enough that trying to consolidate a universal information model might not be, it's worth trying to do, but it might not pan out.
An information model isn't how you encode it or how you implement it, but it goes to the precision that we think is needed.
Sure.
And having a common understanding of units and precision, I think, is pretty important. And you can argue, I think you can argue whether or not it's a requirement or not, but I think we don't want to look at the individual solutions. We need commonality here so that this individual to inform the individual solutions.
I think it's worth looking at. There's value in trying to do it probably, but doing it in this document, probably not.
Just to jump in a moment. So we have locked the queue. We do have 3, maybe 4 others in the queue. We want to get through those questions, but if there's a point of discussion, we do ask that it go to the mailing list to capture.
Kenji, China Mobile. I think you mentioned like you want to get a planned change for the modeling work. It's like you try to get some predictability about the information here. And then at the end you say, okay, you do not care about how it's going to be collected. So I try to think about it. Say, suppose you do define a perfect model, and then you do not care how those model, how the information related to those model will be collected. So I just clarification in my mind later how the field will will use your model.
So the expectation here is to draw an analogy with existing systems, existing management, existing protocols, is that um, the quality of what, so a network operator has their plan and hopefully their model of what's actually in their network, but it's up to the person who's managing that data to adjudicate and to discriminate of how much they want to model. If they only want to model fixed assets, if they want to model user assets, if they want to model some subset of a network or the whole thing, that's the kind of level of detail that we can't enforce. We can say, when you choose to scale your model, what should you consider? But we can't tell an operator, an ISP, what aspects of their network they intend on modeling.
Okay, in that case, maybe you should leave extensibility in your modeling work to say, okay, later something can be added there instead of just restrict something for the boundary. Yeah.
Rashmit here. Thanks for the good work. Actually, this is very interesting. So I was wondering, just a quick question. When we talk about some of these parameters that you outlined here, we are considering the fact that they themselves could be variable as well. Like periodicity, for example, I'm allowed to actually change the periodicity of the schedule, right?
Yes.
Right.
Yeah, and that's also that distinction between the schedule time and wall clock
And
time
wall
is
clock,
that within a schedule, these things wouldn't change, but as a schedule changes over time, yes.
Right. And the other comment is, if you're going to hook this up to the routing system, for example, because of the way the routing system works, some of these schedule might not allow enough time for routing, for example, to converge. So these are the type of things that we have to consider when we go to the next step of this thing, and make sure that for example, if the resolution is too tight, then your routing system will never converge. It keeps going and going and going, right?
Yeah. That is a good point, that the time precision works in both directions. That
Right.
You don't want it to be too small or too large.
That's right. Yeah.
Gargi again. So my comment is kind of related to what Arashmit said and my first earlier comment. So you had said that in the scope of this is the planned windows, right? So if there is a planned schedule which says that time T1 to T2 is the window and that's what we're going to focus on. And yes, over time it can change and T2 can become T2 prime. But instead, if the actual window becomes T1 to T3, either because an unplanned event happened during the planned window or maybe convergence is taking longer. So it will be good to clarify the scope that will the model here detect the actual end of the scheduled window based on real events? Will it be able to detect that T3, it should be extended from T2 to T3 for the window to end?
So yeah, so
and whether that's in the scope, like it'll be good to clarify that.
it's a good point. The point, the scope of the model, the scope of any TVR model is going to be bounded by what information is known at the time, and what we're not, at least I would not anticipate that we're not going to start getting into sort of feedback learning type systems that would, you certainly could do it outside the model to feedback reality into the model and collect metrics about how valid is your schedule based on what's actually happened. But here we're just focused on not going back to the earlier question. We're not focused on where does this data come from the model. We're just focused on what does it look like.
Yeah, but it'll be good to clarify that these example edge cases are either in the scope or not in the scope or complementary and should be looked into.
Yeah.
And just a request back to please make those notations also on the mailing list so that we also have the record there. With that, thank you, Brian. we now have two presentations related to Yang data models for schedules and link schedules, followed by a third smaller presentation related to some overlap that may be between them. So we'll start with our next presenter is going to be Eric Kinsey, and we'll get his slides up. We'll eventually get his slides up.
Good afternoon. My name is Eric Kinsey, and I will be discussing the link availability draft. Next. All right, so the goal of this work is to provide a way to describe time variant links so that systems that are able to make predictions about such things have a way to convey that information to systems that would process it. Generally, divided the use cases up here into two rather broad categories. One for the distributed case where individual routers would process this kind of information, and another category where control is a bit more centralized, and it'd be something that would process this availability information on behalf of the routers. Although before I go any farther with this, I will point out that the draft that I uploaded had all of the data marked read only, which of course doesn't work here. So that will be corrected in the next iteration. Next. All right, so a quick overview. This draft does define a new Yang module, and the module contains a list of links, the times at which they are available for use, and optionally some attributes of those links. It's not meant to compete with a network topology model. It's certainly inadequate for that. But it could certainly be used in conjunction with one. And there's no reason that the node identifiers used in the availability data, couldn't match those used in your topology model. I think I've probably covered this next bullet, so I'll just say that there is a slide later that deals a bit with resource planning. Next. All right, so generally, the way I would see this being used is that, there is some system that can make predictions about these things, and it would do so on a periodic basis. And each time that it makes an update to this list, those updates would have to be provided to the interested parties. And when those systems receive these updates, it is possible in some cases that they have to make some small decisions about what to do with the data, because a couple of the attributes can also be measured. And if there are measured values available, then you have to choose one or the other. I think the rule of thumb here is that you choose the one that is less flattering to the network. So if it's a link speed that has been measured, and you choose the lower link speed to work with, and if it's latency, you would choose the larger latency to work with. So examining the distributed case a little further, one possible thing that could be done with this data is that existing IGP metrics could be populated with values from the availability list. So meaning that, when a link comes up, the router could consult the availability list to see if there's an entry there with a matching link and time, and if so, borrow values from the attributes there to fill in its metrics. There is also some work being done on IGP metrics with time constraints built into them. And if you decided to go that way, then I think it'd be a very direct transcription of availability data into that metric. Next. All right, so here's a couple of things that involve a little more advanced planning. And I think an easy one to think about is the make before break kind of strategy, where if we know that there's a link that's about to go down soon, then it would make sense, of course, to migrate traffic off of that link onto one that we expect to stick around a bit longer. And then this next example is one with even a little more planning. So in this case, we might have an upcoming traffic flow that we'd like to support. That in this diagram, you would move generally left to right, so in through router A and out through router D, and we have a choice of paths. If we know what the source and destination of this traffic flow is and when we expect to see it, then we can examine the availabilities and make sure that we're choosing a path that will be up for the longest time possible. So in this case, link A2 is down for part of that time, and so we'd probably choose the A1 B1 path instead. There's a diagram of the module structure. I won't say too much about it here because I think it's probably easier to examine this part in the document. I'll just say that there's I tried to keep the structure as simple as possible, and so it's fairly flat. And so for things like changes in attribute, those would result in an additional list entry where the ending time of one range would be the starting time of the next, indicating that there's no change in operational state, just that some attribute of the link is has changed. Next. All right. So we have already received some feedback on the mailing list, and so I've tried to capture some of that here. Most of the things were, or at least half of them were, about perhaps more efficient representations of certain kinds of scenarios. For example, an entire node going down and coming back would still have to be represented by one entry for every link that it had. Anyways, next, I believe. All right, so like I said, we have received some feedback already. It would be great to get some more. Anyone who has an opinion on this is certainly welcome to comment on it. And the last item is, as was mentioned, there is another draft in this working group that is similar in nature, but certainly covers different use cases. And we do plan to work with the authors of that draft on a common document. I think that's it. Full time for questions, maybe?
Any questions?
This is Brian Cepas again. It would be, I think, helpful to follow the existing Yang network topology model as a basis for what you're doing, only in the sense of not having to redefine nodes and links and the other related things. So this could be an augmentation of that base model. It might be helpful.
Sunny on ZTE. Like I said in the mailing list, I think this ECM model is more as more like I thinking about the YAM model. So I think this YAM model has defined the source information and it's useful for the routing calculation. So I think it's good. But I think it's also there are something to be filled because the scheduled information may be less in the model. So I think it can be improved. Yeah.
Thank you.
I see that you got a couple of question marks in front of a couple of attributes. Are you still working on those, or they're still questionable in terms of whether we're going to add them or not?
Oh, I'm sorry, there are question marks in front of?
In front of, like, say, when I look at delay, you have a question mark in front of it. Does it mean that we are still not sure whether they're going to be part of the model or not?
Oh, no, the question marks here indicate that those leaves are optional.
Oh, I see. Okay, yeah. So, and one question to just clarify things. So we are not assuming anything about how this model is, how this would to be distributed, whether it's centralized distribution or, because in some cases, like satellites, we can easily distribute this to entire constellation, so everybody knows about everything. And in the other cases, when we are, individual nodes can actually distribute this information about themselves.
That's true. There is no assumptions made about that, and yeah, I mean, even as making a subscription to receive updates is another possible approach, which I think would work well with it.
Thank you.
All right, thank you very much. Then our next presenter is Zach.
Hello, this is Yingzhen again. So I'm gonna present another data model for the scheduled attributes. So first I need to claim, different from Eric's model, this model is really a device model. It's used to, you can think of it as to configure it on a router. And also, I think the second presentation about requirement about mentioned the ISIM temporality model. So I actually did have a look at that model, and but this one is way simplified from that one. And so what we are trying to do in this model is to specify a grouping for an attribute that changes with a recurring schedule. And this grouping can be used to augment any existing models. I actually have a couple of augmentations in the draft, and I will talk about them in details. What this model is now trying to define is protocol extensions. So for example, this model can be used to extend an OSPF protocol with a time varying interface cost. But how the protocol act upon this model should be defined by the protocol, not this model. Next, please. Yeah. So here shows the grouping of the schedule definition. So we have a schedule lifetime. This can be, you can define the schedule as always, which means, once you define the schedule, it will be put into action right away after the configuration. And you can also define a start end time. You can define, start tomorrow until infinity, without really an end time. Or you can specify it's only valid for a couple of days. And we do have a recurrence that specifies the repetition pattern of the schedule. We have a base schedule. So for example, it's repeated based on, it's on a daily basis or weekly basis. Whatever you want to define, this is enough. It can be defined differently. And we also have this anyway, so we have a default value. That's why it's become recurrent. Anyway, so the default value actually defines, so within the space schedule, you don't have to make it a consistent. For example, you have a daily schedule. you don't have to define this consistently, continuously for 24 hours. So you can have a default value and you only specify some periods during this 24 hours as the different value. And then for the rest of the period, it will use the default value. Next slide, please. So this is what we have in the draft is to augment the existing IETF interface model, the RFC 8343, with a scheduled interface up and down event. So that's just you can see how it can be used to augment existing model. Next slide, please. This one is to augment the LNE model that's defined in RFC 8530. So basically, this is more like a, you think about it, it's like a node level up and down event. So you can have a node up and scheduled on and off based on a schedule. Next slide, please. So this one, I actually have it in appendix. It use OSPF protocol as an example. You can augment the OSPF interface with a scheduled cost. So yeah, but from model point of view, we only tell OSPF protocol here, that's a scheduled cost. The protocol's action will be defined by the protocol. Yeah. Next slide, please. So this is an example how the grouping can be used to define a real schedule. So to make it simple, I just have a 2-day schedule. Each day for every 24 hours, we have like from 1 a.m. to 5 a.m. and 20 to 23 o'clock, the router will be off. And for the rest of the time, it's on. Yeah, so I don't know whether that's clear or not, but basically it's a 2-day schedule with a daily repetition. Next slide. But I want to bring some discussion point. So we have this recurrence, but it does cause some ambiguities. So for example, when does a week start? And if we have a monthly schedule, what's a month? We have 28, 29, 30, 31 days. If we define this schedule to be 31 days, what do we do in February about what happens after 28? And even for years, we have 365, 366. So we got to make that clear. And what should happen after a schedule ends? So all those are open discussions. We want to get feedback from the working group. How do we want to deal with things? Or even like you say, I have a daily schedule, right? That's the base schedule is daily. But you define your schedule to be effective right away, but you start from 12 o'clock. Should the day start from 12 o'clock then, or you should start every day from 12 o'clock in the evening, right? Yeah. So, but all those are open discussion points. So we want to get feedbacks from the working group. Next. And I think the next step, I will leave this to AC talk about the combining of the two models together. And of course, this model will continue to evolve as the use case document, problem statement, and the requirements of this working group evolves. Yeah. Thank you. Any question?
Thank you very much. And we have 2 members in the queue.
Just a quick note that some of these might be actually location bound. So you want to exactly turn off or turn on in a particular interface, not based on time, but based on locations. And for example, the satellite is on top of a particular area on Earth. You want to actually close up that particular interface to the left or right and up and down. So that might actually be something you want to consider.
Okay. Based on location.
Like Brian Sebas, I think that this model is a really good starting point, and there are some aspects of Yang modeling that are related to any data that I can talk to you about later that might be even helpful in making this more general, more usable across lots of different models. And the notion that you brought up about what is a month, what is a year, these kind of things also would be valuable to feed back into the TVR requirements. And maybe the answer is just to say these systems should not model anything that is not well defined to be a specific number of seconds or whatever the domain is.
Yeah, probably like our repetition or daily, those are the ones that are more solid without much ambiguities.
三点章 ZTE, I think, in my opinion, this schedule detail in the Yang model has been defined very clearly. I think it's very good. But I think that all the other information is not enough to for the nodes to do the routing calculation. So I think maybe this model and plus the Ericsson model can do the things. So I think the merge of the 2 Yang drafts will be benefit to for the working group. Yeah, that's my opinion.
Okay, so you will see our merge plan soon.
I know we had locked the queue, but as I bring the new slides up, Mark, if you wanted to mention something.
Mark Blanchet. So someone on the chat said about using iCal. Not sure iCal is the right thing, but we may want to look at this for all the calendar kind of stuff, recurrence and all this, because this work has been, dealt way down into all the weeds for iCalendars, and so we don't want to import everything, but you may want to look at this as an inspiration of something.
If there already,
because there's a lot of devils in the details in this.
Yeah, I believe this has been discussed a lot of times before. So if there is a clear definition, people reach agreement to that, we'll be happy to use it.
Thank you so much.
Hi, I'm AC Linden. We, the authors of the 2 drafts, not just at least most of us met yesterday to talk about merging the drafts, and we think we have a good path forward. I'm going to go back pretty quickly. I want to thank Sandy for being the plant to ask for this. Anyway, go ahead. So we have those are like I said, and like both the authors said, these are different use cases. One is sort of the IETF link availability covers a whole topology and multiple nodes and has a schedule for all of them, whereas TVR schedule is a device model. And but there is enough commonality. We think we can get some common groupings, both for the schedule and the lifetime of the schedule and everything, agree on that. And so even though we're merging them, we'd like to get comments on how you think we did it, because in one case we have both the recurrence and offsets from the given recurrence, and in the other ones we have a list of specific times. Both are lists. You can do multiple events. And then I thought that was interesting. Was that you, Brian, who said something about doing something to make it more generalized? Yeah. As to what we do, we want to do more than just link up and down. We want to agree on the attributes and make that common as well, and then move forward. with a single model that has probably 3 models. Next slide. Yeah, probably 3 models, a common model, and then a separate model for each of the use cases that makes use of the groupings in the common model. That's the direction right now, but we may find something else out based on working group feedback and working on it more. Thanks.
Thank you, and thank you for the authors for meeting and looking for ways to merge this work. Our next presentation is Marc Blanchet, who is going to be talking about a contact plan Yang model.
Should be very short. So I presented a contact plan format in JSON last time based on the requirements or the actual implementations of bundled protocol for the DTN use case. Since then, next slide. Since then, added 2 new co-authors, Ying Zhen and Lee Torgerson, is now a Yang model augmentation of the previous schedule model that was presented and augmented over the bundled protocol Yang model that has been presented yesterday at the DTN working group, and adding some properties for the bundled protocol stacks like plan delay for that contact or that link. Next slide. So this is very basic, as you could see. And next slide. So one of the question is, should the augmentation be not applied to the convergence layer adapter or the neighbor? Convergence layer adapter is really the one which is the right thing. And should we add all properties and use in BP stacks such as bandwidth, probability, and stuff? And I'm referring to AC last presentation, which is maybe after the merge of the two, that kind of consideration may go away or change. So, so therefore, I don't know if I have another slide. Yeah. So I think we should keep this on the side, wait for the work of the co-authors, and see what to do next to apply the result of this over a bundle. Questions?
Any questions? We do see a few.
Cool.
Brian?
Yeah, Brian Siebes. I also think here, if you were to cast the BP definition in as a Yang network topology, then you could both operate as augmentations on that network topology, and you wouldn't be stepping on each other's toes or necessarily need to coordinate until you try to actually put them to use.
Your comment should have been said in the DTN working group, actually, because that's the bundle thing part, which is,
We'll cross-reference the notes.
One delay of 1 day for your comment is like.
Rick Taylor, another one with a 1 day delay, but that's the nature of DTN.
Yeah.
I think addressing your point about the difference between bundle protocol attributes and CLA attributes, I almost wonder whether those are two models, because one you're modeling link layer state and one you're modeling sort of topological information. I'd be interested to see whether it makes more sense splitting it in some way, maybe within one model with 2 separate trees, or I'll read and provide feedback and help.
Yeah, I think we should keep this in mind, but I was kind of waiting for the group of others to.
I think waiting is a really good idea.
Well, actually being involved at the same time, but this yesterday I said, let's make sure that my use case is still, in the merge, or not my use case.
All right. Thank you very much. Our next presenter is for Alto.
Hello, everyone. This is Luis Contreras from Telefónica. I will present this idea of using Alto for exposing TVR information. So next, please. So as a sort of background, just reminding the presentation that I did in Yokohama. So the idea is to leverage on Alto to expose the anticipated changes in the topology. Alto has a feature called cost calendar that allows to present different topologies, so in such a way that we can present the present topology and plan schedule changes in the topology in the future. So this leveraging on Alto enables the an off-path mechanism for exposing the planned topological changes. And also something interesting from Alto is that the possibility that be consumed by applications. So in such a way that those changes that are are predictable can be consumed by applications. So the applications will be aware of potential changes in the network. On the right side, or on your left side, sorry, you can see an illustrative architecture. So there could be others that was just set as illustration purposes on how to leverage on Alto for exposing the information. And essentially what the figure says now is that the information could be collected either from a network controller or another possibility maybe to leverage in things like network digital twin and so on and so forth. The fact is that actually Alto will retrieve the current view of the topology plus the possibility of incorporating the plan or schedule changes in another topology. I mean, the topological changes in the cost calendar functionality. Next, please. So the changes from the previous version in the document, so essentially I have elaborated a little bit more on the different strategies for advertising the predicted topological changes. Essentially, we are describing two mechanisms by means of a network controller as the element that is able to schedule the changes and using Alto for exposing those changes to applications, basically. And the second case would be advertising these changes to the routing protocol. So both of them could be potential mechanisms of potential strategies, let's say, of advertising these changes. Also, we thinking now specifically on Alto, we have described it better. What would be the two different ways of retrieving the information, as said, thinking on Alto? One case could be directly interacting with the network controller. So the network controller brings the element that calculates the different changes due to the plan topological change, and then pass this information to Alto. The second mechanism would be that Alto integrates directly with routing mechanisms that are conveying this information of the changes. So Alto parses that messages and incorporate those changes into the logic of Alto for later on exposing these to applications. Next, please. So the advantages of the proposed approach are the following. So by leveraging on Alto, it's possible to offload the processing of the changes from the network elements. So the network elements will not necessarily need to process all the changes, especially if we follow this idea of being the network controller, the one calculating the potential changes. So we offload this processing from the network elements. We leave this processing either to the network controller or to the Alto, depending on where we could put the logic of the calculation of the changes. Also, because of that, I mean, because processing, let's say, because of loading the processing of the changes, we also avoid undesirable cascading or propagation effect, in the sense that whatever change that could be incorporated to the routing protocol, and this, I mean, those changes, as long as are being propagated among the different routers, can produce new changes in the routers that are receiving the schedule change. So somehow generating new changes and probably increasing the time of convergence for the overall view of the resulting topology after the desired change. A second benefit that we see with this approach is the following as well. So the network elements are good in propagating information about changes, about the actual or current adjacencies and nodes. So a network node will be aware of what is connected to it, what is attached to it, and then can propagate this change. But it's not so good for, let's say, propagating changes of network elements that are not yet existing. So for that, we will need probably to leverage in a network controller that could instruct or basically instruct the node, hey, there will be a new node here, or you will have a new adjacency between this node and this other node. So Alto fits well in Alto plus the network controller fits well in this idea of propagating changes due to new elements that will appear in the network. So not the ones that are present, but new ones that will appear on the network. And finally, as said before, also the idea that by following, let's say, this approach, also we can make the applications being aware of the topological changes that will happen in the network. So the applications will not have direct access to the routing information, but by using Alto, let's say, they can receive the topological changes and then take some actions in advance to those topological changes. Okay, so next, please. So the next steps, we would like to collect feedback from the working group. Also, thinking on this functionality, this feature, the cost calendar feature from Alto, the idea would be to assess if the parameterization of the models, that the two ones that we have just seen at the time of discussing the scheduling, are somehow compatible with the parameterization that Alto is considering for the cost calendar. So there is a calendarization parameter, how often to present changes, and so on and so forth. So the idea would be to assess if are somehow compatible both ways, no? Because thinking in the case that Alto could consume as well these schedules from the routing protocols. Then, if perceived as necessary, also probably we could add some scenarios that could maybe better argument the fact that the applications can leverage on this information, and that would be beneficial for the applications. We can think in media delivery streaming services, or whatever other kind of service that could be benefited of the fact of knowing in advance schedule changes, so that also the application can take decision of moving flows from one part of the network to another part, so avoiding issues, avoiding problems. And then, if necessary, to refine or improve the architectural figure that they saw at the beginning, because it was just for illustration purposes, but probably we can go, let's say, into more details and providing better description of the case. So with that, I finish, or any comment or feedback is more than welcome. Thank you.
Should we consider using netconf for distribution?
Netconf, you mean?
Yeah, netconf.
Yeah. Well, netconf could be, you mean for configuring Alto?
No, if we're talking about distributing schedule changes.
Toward the network elements, you mean? Yeah, from the controller, yes, for sure. Yeah, the idea would be to use programmatic interfaces. So the controller will govern, let's say, the potential changes, the future changes, but at the same time, advertising or let's say, yeah, informing Alto what will be those changes, so in such a way that Alto can expose to applications. So it will be a coordinated action for the network, let's say, and Alto as well.
I also have a question, chair hat off, but we talked a little bit about contact graph and a model for how we would talk about future contacts. Is Alto, what is the overlap or the relationship between contact graph as an approach and Alto as an approach for predicted and scheduled links?
Well, I'm not so much familiar with the contact graph. I mean, I need to read more about that, so the draft and so. But at the end, well, with Alto, we can also expose the changes in a form of graph. So not sure if this is the essence of the contact stuff, but I need to become more familiar with that. Maybe what I can do is to post in the mailing list once I read the draft with care and comment about the differences or synergies.
That would be appreciated.
Okay.
Just talk to Mark.
Okay. Thank you. Thank you.
All right, our last presentation of the day is Sandy for routing considerations.
Good afternoon, everyone. I'm Sandy Zhang from ZTE. This presentation is for TVR routing considerations. I make the presentation on behalf of co-author. Thank you. Next. So the motivation of this draft is to bring discussion for TVR routing implementation. And we discussed 3 implementation modes in the draft. One is centralized mode, and the other 2 is distributed mode. Next, please. So let's take this figure, for example. The variable node means that the node has scheduled link or cost changes. So the non-variable node means that the node has no scheduled link or cost changes. The domain means that all the nodes in the domain will be affected by the variable node changes. So next, please. So for we compare the 3 modes from 4 perspectives. For the centralized mode, we know that the scheduled young model can be distributed to all the nodes by controller. So no scheduled advertisement, whether the variable node supports routing protocol or not. And the existed routing computation process need to be changed because scheduled information, including link and cost in the young model, needs to be used when computing the routing table. And the delay before the scheduled time is each node own computation delay. Next, please. For the second mode, the first distributed mode, the scheduled young model is configured or distributed to the variable node. The variable node is able to advertise the routing information by routing protocol, for example, OSPF or SIS-eccentric. The variable node advertises the information, including link and cost changing in advance of the scheduled time. The computation process on each node needs not to be modified. So, but the delay before the scheduled time is the network flooding delay plus each node own computation delay. For the second distributed mode, the variable node is not able to advertise the routing information by routing protocol because we know that in cabin-aware network, the node may not have the routing capability. So the node cannot advertise the information by itself. So the scheduled model can be distributed by the agency node, which has the routing capability. We can call this node helper node. The helper node advertises the information, including link and cost changing in advance of the scheduled time. The computation process is also cannot be modified to fulfill the to achieve the goal, the calculation goal. The delay is the same with the distributed mode 1. So it's the network flooding delay plus each node own computation delay. Next. We are not sure if TVR will cover all these modes, but we think that explicit scenarios, deployment scenarios will help the young model design and provide guidance for implementation. So that's what we want to be discussed in the working group. Any comments welcome. Thanks.
Thank you very much.
Yeah. Thank you.
I do have one question for me. Just with we had earlier presentations on requirements for TVR. Is there any? Do you see anything in this work when we talk about the nature of centralized and distributed and route advertisement that should themselves be flowed into either modes or requirements in the requirements document?
Okay. I will read the requirements draft so to see if it's already in it, right?
Or whether it should be added.
Okay. Thank you.
I know we have another some more in the queue. Oh, please. Yes. Ace.
AC Lindum. I was just thinking at least for the IGPs, the distributed mode too, where there's a proxy that would advertise on behalf of someone. I don't know that, I'm trying to think other than redistribution if there's a natural way to do that. I know there is maybe in it would almost seem like the node itself, even if you have somebody advertise on behalf of them, they don't generally have a way where they'd update their own state based on what a proxy is doing. It sort of seemed, I just looked at it and I said, that's something new. Maybe I misunderstood it, but I don't know.
The thinking is from the TVR both, because we learned that somebody makes a pretension for the carbon aware network, and some node is connected the internet by some routing protocol, routing nodes, but itself has no routing capability. So so I think he can't do the advertisement by himself. Yeah.
Okay, so it wouldn't be on behalf of someone who would do the advertisement in the traditional case. He would this proxy would do the advertisement in all cases. Yeah. Okay, that makes more sense. Thanks.
Thank you. Any other comments?
Just to add something here, it's not necessarily the neighbors. One can actually do this thing on behalf of a whole set of nodes, right?
Thank you.
Thank you so much.
That's the end of our formal program for today. We now have open mic time. Anyone and anything.
I don't remember who it was, but somebody said that you could have things changed on location. Is that within charter as well? Yes, but is that within the charter of, I don't know.
Rick Taylor, space and time are surely, according to Einstein, entirely resolvable between the two. I believe space is out of scope for the charter on the grounds that most things that are moving in space have some kind of time-based schedule and will approximate it like that. But a chair or an AD is welcome to tell me I'm wrong.
I don't know of a reason to preclude it at this point. I will point out that if you specify a schedule based on where some third-party location is, the rest of the network's going to have a hard time understanding what you mean, because they won't have location information on some remote node.
Yeah, it's interesting problem space. I take it to the chat. Just Rick Taylor, my point I stepped to the mic to say was, I think there's some really good stuff happening. I just wanted to say thank you to everyone who's put in all the hard work, because we've got 2 or 3 people looking, or leading teams looking really hard at scheduling and tackling the Yang problems. There's really good stuff for this is second working group session in person. This is great. So thank you, guys.
Do we call it? All right. Thank you, everyone. Please stay active on the mailing list, and we will see you at 118.